Hello, and today I want to talk about writing the equation of a line. The objective of this lesson is twofold. One is to find the equation of a line given the slope and a point, and write the equation from a graph, table, or 2 points. So let's go ahead and get started. The thing I want to talk about is the point-slope form. The point-slope form is an equation for a line. Looks something like this: is y minus y1 equals m times x minus x1. That's actually a typo. It's supposed to be x minus x1. So let's fix that. Right now that's an x1. And you use this to find the equation of the line in y equals mx plus b form. So let's do a quick little example. What if I gave you the slope was 4, and I told you that it went through the point 3, 8. Well, if I told you that, then what you need to do is, first off, you can use this formula, the y minus y1 equals m times x minus x1 formula. I'm going to label this x1, I'm going to label this y1. So now what I do is I go ahead and plug it into my formula. Y minus y1, which is an 8, is equal to 4 times x minus 3. And then I go ahead and I do the distributive property. And I get y minus 8 equals 4x minus 12. Next step I got to do is add the 8. And my equation is y equals 4x minus 4. So now I've written the equation of a line in slope-intercept form given one point and the slope of the line. Let's take a look at another example. It says find the equation of a line in slope-intercept form with a slope of 2 and goes through negative 3, 5. So you could use this formula, y minus y1 equals m times x minus x1. Now in here we have, this is our x1, this is our y1, and that is our slope m. So let's plug it in. Y minus 5 equals 2 times x minus a minus 3. Here you get y minus a 5 equals 2 times x plus 3. Let's go ahead and distribute. And then we will add our 5. And so now you're left with y equals 2x plus 11. So your equation for your line has been found. It is y equals 2x plus 11. Another example before we move on to the next thing. This one has a slope of 4, so m is 4, and the point is 5, 3. Actually, we just did that one, I believe. Nope. So you use the y minus y1 is equal to m times x minus x1. Here you put in the equation y minus 3 is equal to 4 times x minus 5. Using the distributive property, you get y minus 3 is equal to 4x minus 20. And then we add 3 here, and we add 3 here, and we get an equation y equals 4x minus 17. Pretty simple. But now let's look at something a little more complex. Okay? At finding the equation given 2 points. Now in your guided notes it says something about how to do this. The first thing you need to do is, since you're given 2 points, is to find the slope. Then take your slope, one of your 2 points, plug it into the point slope formula, and solve it for y. So the first thing I'm going to do when I see this is I'm going to label my points x1, y1, x2, y2. And I'm going to use the slope formula y2 minus y1 over x2 minus x1. So when I do that, I now have 3 minus a minus 1 over negative 3 minus 5, which is 3 plus 1 over negative 8, which becomes 4 over a negative 8. So my slope is 1/2. Negative 1/2. I'm going to take my negative 1/2 in any one of the 2 points that I have. In this case, I'm going to take 5 and negative 1. I'm going to plug it into the equation y minus a minus 1 equals the slope times x minus 5. So then I get y plus 1 equals negative 1/2 x plus 5 halves. And then I'm going to subtract 1, and this is where it gets a little tricky. I'm going to subtract 1, which is 2 over 2. And my equation now is y equals negative 1/2 x minus 3 over, or plus 3 over 2. Not a very pretty equation, but it still is equation. The slope is negative 1/2, and the y-intercept is 3 over 2. Let's do another one. Again, we're going to use the slope formula. So we're going to use y2 minus y1 all over x2 minus x1. And we plug it in. How about negative 2 minus a 7 all over negative 4 minus an 8? That gets us a negative 9 over a negative 12. When we reduce that, I believe that gives us a positive 3/4. Now I'm going to pick my most positive point. That would be 8, 7. Instead of the negative 4, negative 2. But you could use either one, it would still work. You plug it in, y minus 7 is equal to 3/4 times x minus 8. I plug this into the y minus y1 equals m times x minus x1 equation. So then now I distribute, so I get y minus 7 equals 3/4 x minus 24 over 4. What I get now is y minus 7 equals 3/4 x minus 6. Then I add 7 to both sides, and so now my equation is y equals 3/4 x plus 1. Okay? Let's take a look at a real-life application. Okay? A printer charges $65 for 100 copies of a booklet and $105 for 500 copies. Assume that the relationship between the number of copies and the cost is linear. Write an equation relating the cost and the number of copies. How many copies can be printed for $200? So the first thing you got to think about is this is in fact 2 points. The number of copies depends on the cost. For this, you got to think about it's going to be cost per copy. So really we have a point 100 comma 65, and we have the point 500 comma 105. So we're going to use those two to find our slope and all of that. So let's go ahead and use that. So we're going to go 105 minus 65 over 500 minus 100, which I believe you get 40 over 400, which is 1/10. So your slope is 1/10, and we can use this point in our equation. So we have y minus 65 is equal to 1/10 times x minus 100. When we do this, you get y minus 65 equals 1/10 x minus 10. Add 65 to both sides. And when you add 65, you get y equals 1/10 x plus 75. That is your equation. Now, for how many for 200? They wanted it for 200. I believe it was. So they wanted it for $200. We have the equation. We have the equation y equals 1/10 x plus 75. Now they gave us $200. This is $200. So the question is, does it go in for the x, or does it go in for the y? Well, x is the number of copies, so we're actually going to be creative here and put this in for 200, and we equal 1/10 x plus 75. Here we subtract 75, you get 125 is equal to 1/10 x. And then you multiply both sides by 10, and you get 1,250 is equal to x. So for $200, you can make 1,250 copies. So that's the end of the lesson. I hope that this works for you, and I hope to see you soon, and may the force be with you.